Hello friends, I am Dr. Arpit Bhardwaj, Assistant Professor, Computer Science Engineering Department, Bennett University. The topic for my today's lecture is genetic programming. The content for my today's lecture is Introduction of Genetic Programming, Genetic Programming Life Cycle, Initial Population Generation. Introduction of Genetic Programming. Genetic programming is developed by John Arcosa in early 90s. Based on Darwin's theory of natural evolution, that is, survival of the fittest. It is an evolutionary algorithm based methodology, means in this solutions are evolved at each generation. We do not get a solution in a single step. It is inspired by biological evolution, means individuals can interact with each other to generate other individuals. Even a single parent can generate its offspring. In memory, genetic programming programs are represented as tree structures, where the internal nodes are the arithmetic operators such as plus, minus, into, divide, and the terminal or leaf nodes are feature variables or randomly generated constants. This is an example of mathematical expression written in the form of a GP tree. Genetic programming life cycle. The first step of genetic programming life cycle is to create population of programs in the form of a tree structure. After that, we evaluate the fitness of each program using the training data. In this step, we measure how well a program has learned to predict outputs from inputs. After the second step, the initial population of genetic programming life cycle is created. And then we apply genetic operators like reproduction, crossover, and mutation to modify population of programs to get new generation. Then we terminate the genetic programming life cycle if a good program is found or we reach the total number of generations. Else, we go to step 2. Following are the genetic programming steps required to generate a best classifier for a classification problem. The steps are creating an individual, generating a population, fitness function, selection, genetic operators, termination of GP. Now let's see each step of the genetic programming life cycle in detail. The first step is creating an individual. To create an individual, we require two types of set, functional set and terminal set. Here the functional set is represented by F and the terminal set is represented by T. The functional set is composed of unary and binary arithmetic operators. The unary operators requires only the left child, whereas the binary operators requires both left and right child. The example of unary operators are sine, cos, tan and power functions, whereas the examples of binary operators are plus, minus, into, divide. Here division operator is protected division, which means divided by 0 is considered as 0 rather than infinity. The terminal set consists of two things, feature variable from the datasets and the randomly generated constants. Randomly generated constants can range from 0 to 100 depending upon the problem. The randomly generated constant is basically used for bringing the diversity among the solution. It may or may not be the part of terminal set depending upon the problem. In this slide, an example of iris dataset is given to understand what are features in the dataset. The iris dataset has three classes, iris sedosa, iris versicolor and iris virginica. Out of these three classes, the samples of two classes, that is iris sedosa and iris versicolor, is given in this slide. These classes are classified based on these four features. The four features are petal length, petal width, sepal length and sepal width. Therefore, these four features become part of our terminal set if we wanted to classify the iris class. How to create an individual? When we create an individual, the first node, also known as the root node, is taken from the functional set. We choose randomly from the arithmetic operators and any arithmetic operator can become the root node. In this example, plus operator has become the root node. The plus operator is a binary operator, therefore the left and right child of the root node is created. If the root node is unary, then only the left child is created. Then we come to the left child of the root node. Here we have option to choose it either from the terminal set or a functional set. In this example, we randomly choose X feature from the terminal set. Now this node can't grow because we have chosen this node from the terminal set. Now we come to the right child of the tree. Here also we will randomly choose the value of the node either from the functional set or the terminal set. In this example, we choose minus operator from the functional set. Now the two child of this node will be created. Again we follow the above procedure and form this tree. This is how an individual tree has been created. Generating population. In genetic programming, we evolve the population of solutions rather than a single individual to reach to the desired solution. So for generating a population, three methods are used: grow, full, and rammed half and half. Grow method. We understand the grow method with the help of an example. We wanted to build an individual of maximum depth 2. So in grow method, we have the option to choose function set or terminal set at depth 1. This means that either the left tree or the right tree or both can stop at depth 1. In the given example, the left tree has chosen X feature from terminal set. So it stopped at depth 1, whereas the right subtree chooses plus from the function set and grows till depth 2. We generate all the trees of the population using the above procedure in grow method. Full method. In full method, each tree grows to its maximum depth in the population. For example, if we wanted to grow tree till depth 2, then neither the left child nor the right child of the tree at depth 1 can be chosen from terminal set. It has to be from the functional set. Rammed half and half. This method is a combination of full and grow method. That means half of the tree of the population is generated using grow method and other half of the population is generated using full method. It is one of the most used method to generate the population in genetic programming because it brings diversity among the individuals. Now comes the fitness function. It is one of the most important function of genetic programming. Fitness function measures how well a program has learned to predict output from the input. For a classifier, the fitness function is the ratio of total samples correctly classified by the classifier to the total number of samples. This completes our initial population generation. After this, we evolve the solution using genetic operators. This completes our first video on genetic programming. In next video, we'll explain how genetic programming operators evolve the solutions to reach the desired solution. Thank you.